Next, we are going to create unit tests for product repository check inventory availability, I think. So based on the past parameter by product ID and the quantity, so it will check product exists, product in stock, and inventory quantity greater or equal to the quantity parameter. Let's go say, go to the product repository test, create a fact, and which will public async ask, and this will be check inventory availability async, and this should return true. The happy path scenario, the user enter the normally used data, and which is happy, and one inventory is available. If it's available, and then we will first say, let's say 3A arrange, and act assert. For the arrange, we say we use the fixture to build a product. Product will be fixture read product, and we specify this product with we say first they say it's available, e to product goes to product. Okay. Product out in stock and which will return true, and build picture dot build not create build, and dot this, and p goes to p inventory quantity equal to 10. We build a product and go to us to the product repository. We say the context at products and add async this async of product. Dot create build dot create, and so then we do saves. So now we have the test data and mark the test data, so you can say run the method of check availability away system on the test dot check inventory availability, and we pass the test data product.id and the quantity, and we go set to 10, we say 5, and we say we assert result should be true, and let's write this one. This one. Run this one. Oh, it's passed. And next, we will test edge case. So fact of let's say it's not happy path scenario, and we say true to return false when inventory is not available. Not available. So in this time we set the quantity of 3, and we still check the quantity of 5, and let's run this. Should be return false. False. And now we run. Okay, then pass this. And also one test the edge case of when the product is not in stock. When product not in stock. Product not in stock. So this in stock will be false. So no matter this number is whatever, it will return false. We check this. It will return false, and it's passed. And get products by ID, I think by passing an array of products. So let's create a get products by IDs, I think. To test this. So let's say fact and replacing task get products by ID sync. This should return products one in the scenario products exists the product is this. So what we are going to do is copy this. We mark the data, arrange, we mark the data first. So in this, we say, instead of creating this product, we just say the picture dot, we can create many and type of product, number of 3, and to list, type of list, and we get these products, and so we need get these products to be saved into our context products entity. So get range of products, and we save to the database. So one that we need to say, we get the products ID IDs equal to products. That's use a select, the link of select, which we pass the lambda goes to the products goes to the ID and dot to list. We select only the IDs and form it into a list. So the result will be the act will be system on the test, and we want test the method of get products by IDs, I think, and we pass product IDs as parameter. And the result should be equivalent. So check the and highlight to and products. And we can test this get products by ID should return plus one product exists. No. IDs. The two actually it's array, right? Array and a, and it's good. The next we just say not the product is not exists, and we can just say products ID. What happened is products ID, we just create a new array, new int array, and this array will be 1, 2, 3, and we say be equal instead be equivalent to this, but empty. and get to the return empty list, empty list when product node exists. So that's right. And we test it. Okay. So now we have that. Let's see. Subtract and this check inventory availability and get products by IDs. All right. So we have the unit test for this product repository. Okay, so next we are going to test the product service. So to test the product service, you see we have the dependency of unit of work mapper, and also you can see we have the product repository. It need to be marked. So let's go to our test project and create a new folder for service test services, and we say add a new class, and this will be product service test. Right. So this is our product service test. Service test and and we have some we need that all the product service dependencies. We need a local variable to inject a local variable for that product service. So we need a first unit of work, and second is the mapper. So let's create a read-only, and we mark this object of a unit of work. Unit of work. We mark this, and this will be unit of work. And we say private read-only mark the mapper. So instead of the real mapper, we just say mark mapper and mapper. And this is mapper mark. And so for this and the system at test, the system at the test will be private and only product service. So this is the service we're going to test. Product service. And this is a system on the test. And for our constructor, public systems. For this, we say we mark the unit of work, which is equal to new mark of a unit of work, and mapper mark, we will say new mark of interface of mapper, and then we can say system on the test, which will be new. We created a product service with the dependency of unit of work object. It's instantiate of return object, and also the mapper mark dot object. We pass these two dependency. We got a system on the test, and also we need a fixture, right? Read only by fixture of the auto fixture. So this we can say fixture equal to new fixture. Equal to product fixture. Remember, we have the customized fixture instead of the general. I create a fixture. So this is our product fixture, and so remember this unit for work actually it has a dependency of product repository. So we need to mark the product repository. So let's say private read only mark by product repository. This is product. We can say product repository mark, and this will be let's see product repository mark equal to new mark of a product repository, and the unit of work which need this dependency. So we need to set up this. I need to set up the product repository unit of work products. It says in unit of work called products, and this should return Yes. So this product repository object. So then, and we can just mark the product repository to follow all the unit tests. So you can see the product service like it calls everything. It calls the product repository delete, so we can verify it's being called. And let's say product service. Let's say get all products. So we'll say unit of cloud product repository get all async. And let's say we create a fact is public async get all async complete products async. This should return our product. So happy case return to return all products will be happier or happy. And let's say AAA arrange act or search arrange we say we mark the product repository, and first we created a test products data. Products which equal to the fixture. Use fixture to create many what type of product, and how many 3, and then to list. And for this product repository mark is set up. So we have this product repository mark. Which method we called is repo. But the repo we call to the repositories get all async method. So this service get all products async calls repos get all async method. And this returns async of products. So it return our test data. And we call this system on the this system on the test get all products async. And what we assert is the test data is returned by the get all async get all products async. So this result should this actually this object will be equivalent equivalent to product. All right, and our first system unit has get all products. Async should return all products. Let's see. Oh, that's what happened. Oh, okay. Oh, okay. What we didn't do is this. Remember, this is async method. We need await. Instead of return a task, and it will be return list, and that's why we run, and it passed. So and we say get products by ID async is almost the same. Let's quickly create a unit test for get product by ID async. Let's say this and they get products by ID async feature ID. Get product by ID async, and what the condition, the scenario is with happy copy that scenario with valid ID, and this should return product. And this range will be create one product, pass product, and the right side mark reverse side return. This will be called to get by ID async of product ID return product. We set up the product repository mark, and the result will be called to get a the test will call to this method. Get product by ID async. And this should be the result will be equivalent to product, and let's test this. Oh, it's passed. Okay, so that's happy case and product service. Create, update, patch, delete, create. Okay, great. So let's say fact of create product async. Create a product async through the it should return rated product, and we will arrange. Actually, we have product detail, product detail equal to texture that rate, the type of rate product detail, and so this we need to set up the product repository, and you can see it has a mapper. Master mapper will map the product detail to a product. So in that case, we can see and so let's say no, let's say it's the mapper mark. Mapper mark setup. Setup what? It's setup by mapper. Goes to mapper dot map mapper dot return type of product and the parameter of product detail and returns product. So we say if we pass the product detail to the mapper and the micro markup will returns this product, and this product repository setup will be, we say, repos add async, because we call the repos add async, and this will be anything, right? Anything is a product. Is any at least you just say anything, and as far as it is a product type. So if the parameter is anything and it's a product type, so this will returns it. Think of product. And we also want to test the product service. So it will return products, right? And so now in that case will be the product repository mark. So Guide by ID async. Guide by ID async, and this parameter will be product.id. If this will return that our test product. And also one more arrangement. One more is unit of work will run that save change this thing. Unit of work, and it will run if new w post unit of work. So they change the thing out, return async 1. And in that case, if we call is create product async, the result will be called the system under tests create product async, and this is product detail. And the result should be equivalent to product. Okay. Oh, third product. No. So we say we have we have some hidden paths. Okay, so this we need to check the product service, and you can see with the product create product async. We added a product here. So what happened is this ID product, which equal to unit work product repository ID sync product. So we need to return this project instead of the my project. So this, let's change this and run the test. Okay, it passed. Okay. So next, let's test update and delete. Let's say update product async to the return updated product updated product So for this range, we say data var product ID equal to texture at rate integer on the rate integer. Okay, so the product detail will be update product detail, and the product will be product type, and then we make we first set up the product repository. Marks we set this because update we first need to get the ID, and this will be product ID. This will be return product. So we mark the repository get ID async returns product, and also we set the mapper. Set up the mapper mark. So we say mapper goes to, let's say this mapper map map from product detail update detail to product. This will return our product mark text, and product repository mark will say map repos update async. For this update async of product, and this will be verifiable, and unit of work. And unit of work setup will save change sync will retain sync f1, and we call this update async sync which is product ID and product detail. And then we just assert verify repository called update product once, save async once. Unit of work is save async once. So let's say verify The first one is product repository mark. So we set this verifiable, and then right now we verify goes to repo dot update dot product dot dot absence. So we call it once. We call the product repository calls to that update method once. Also, unit of work will just call calls to goes to unit of work save change, I think, once, and it calls to that update and saves async, and they passed. The same thing for delete. Let's say delete should call the delete the repository delete method and saves async method of the unit of work. So let's say delete product async should return true. And this is a product ID product and this return product, and so we say we don't need this mapper. We set delete async verifiable, delete async to be delete verifiable, and saves async and return one, and then we call delete product async over here, delete product async over here, and we verify delete calls once, delete calls once, and we all recover saves async calls once, and perfect, it success. We can run all the tests now. They all passed. Perfect. Let's close out. So we have the product, and we also can have you say placeholder. So for the orders, you can see orders will have a customer ID, and other items the following key, and it has other item table, and let's say the repository. Let's have older repository. which we can say the all the items which need you don't have a repository for, you only have product repository. In order to place order, we need all order repository. We need all items repository. Let's create repositories, and we say interface. So create a new interface. Order item repository, and we have interface of order item repository will be inherited a generic repository which type specify the order item. Okay, so now we have this order item interface, order item repository interface, and we need a order repository. Let's say we got new interface repository, order repository, and the order repository we inherited generic repository type of order, and let's see order repository. We can say we have I think which is update inventory async, which has a type of int parameter integer product ID, also have a type of quantity, and all right, and use item. Okay. So now let's go to the repository, and we can say other items repository first. Plus order item repository, which we just inherited the generic repository of type of order item, and also we say it a order repository, order item repository, order item repository, and so in order to this, we need quick action generic constructor, and this constructor passes the DB context, which is needed for generic repository, and this will have that. Right. So let's have another class of order repository, order repository, and the repository will be inherited generic repository type of order, and then interface of my order repository, and which has a structure, and else my order repository, which need updated inventory, I think. So we need to implement interface of, and this order repository, you can say first we need overwrite the generic repository. We want to get order items, so let's say public async override this task and return order, which say get ID async. This get async, which has parameter of ID, and in this we say we return that context orders, and this will be include which say order goes to order dot items, right? And then include goes to item goes to item dot product. I don't need every item is good, and they should be first default, I think. And we pass by the order goes to orders ID equal to ID. That's the okay, so we got get by ID, I think, and we can say get by ID, I think, can return now. So go to the generic repository get by ID, which will return now. Get by generic repository, which will say get by ID, I think, return now. Then we say, and that's the gateway sync just will load the other items by overwrite that gateway. So we also want to say instead of just let's say orders, instead of we just say we only add the order, we will also add the other items. So I will place order, I think. Okay, let's go to the let's go to the interface. Order repository. Old repository, and we can say so this we need a task of place order, I think. Place order, so place order, I think we'll have order as a parameter, order, and we go to the order repository, implement this interface, placeholder. So public async task of yeah, it's a task return. So what happens? We want to say we want to say this one will update our inventory after add a new order. So and in task we will say, so what happens, this placeholder will update inventory, and so for each order item it updates the inventory, and but for each item that product inventory will be updated, and it could be if the order quantity item order item quantity is greater than product inventory, we need a rollback, we need a transaction. And so let's go say update the inventory product and a quantity. So let's say product, which will be equal to weight of context of products of first default async, which the p goes to p dot id, product id, and we'll go to product. Product is now is a throw new node not found exception not found exception, which has only the parameter of, let's say, a string exception passed by a let's say product, and then it has a product id not found, not found. For this not found exception, and create a new exception that will cost not found, and error. Okay, and product out we update the inventory quantity equal to quantity current quantity, and plus this could be minus value, right? So if you update minus, and then it will be so now we save the changes. And if or it could be the inventory quantity of the update date, if it could product that inventory quantity, it could be the minus after the update, you can say throw in invalid, and it should be invalid operation exception. And last will be say insufficient inventory. And this is the inventory. And if it's not, we can say product inventory quantity equal to no, the product dot in stock. Which equal to product. So this will be product inventory quantity greater than 0. And that should be true, right? So then we save changes. We only save changes if this will be through exception for that updated inventory less than 0. Other than that, we save changes. So placeholder. Okay, back to placeholder. We can say transaction. We are using a bigger transaction. Let's say using one transaction equal to await context dot database begin transaction async and in this transaction reply page try we say context first select the order select order and wait and the context save change async resaves, but if it's but updated if the update inventory fails, we roll back. So if it's exception of you see we have the insufficient inventory, we roll back, so it will even roll back the order. And in that case, exception we say await transaction. Rollback, I think, and roll. Roll. And for now, successful we commit. But in async operation. Await. And we return order. So if everything is good, we return order. So what happened is add order. So now it's the for the now it's the update inventory. Update one place order, we will get the order, but we will update inventory. So update inventory will be saved for each item in order.items. So this goes to this is auto complete pretty well this time, and we await using our update inventory async of this item dot product ID and item dot quantity, and this is minus, right? Because we place an order, we will that minus the order's quantity, and then we await context save changes in and this is useful in inventory update. Maybe so maybe you won't need, but it's a fun. So these are all the repository. And now we can go to our list of all the repository test class of all the repository tests, order repository test. All the repository tests, they're public. Okay, so generally we need some setup. Let's go to product repository and get back to the order repository. We got the option applying DB context, order repository on the test, order repository and fixture. So maybe order repository test. So we the construction we injected use in-memory database and DB context. Create a DB context, and based on the test will be order repository, and fixture will we reuse the product fixture, and what we need to say, we will change this product picture later, but for now we just say the file state the fact first test that will be goes to fact of or test the ID async. So public right by ID async. Let's show the return order with items one order list and AA arrange fact start range will be we say we create all right, and from order equal to fixture create order orders order order 论的可以看到认为它OK a placeholder Let's say fact. I think task order placeholder. I think this police order. I think should placeholder. Think should be hide order and update inventory when order valid. Order valid. So the happy scenario. So this ways we can say we need a product. Our product equal to create a product and create a product. The product out inventory quantity which equal to 1 and the product out in stock will be true and our product this order will be say let's say new order and that will say order date equal to the time and status will be order status status funding and items will be new list order item goes to new order item and the ID will be product ID is equal to product.id and quantity is less than that inventory, so it will be 1 unit price is equal to product in unit and we say now we place this place order is sync of order and the result is equal to order, and we test it. Okay. Oh, we got invalid operation exception. The error was generated warning of from work.database.transaction. Transaction ignoring. Oh, we have the in-memory database. So the transaction are not supported by in-memory store. So in that case, right now we create a context using in-memory database. So we need SQlite-InMemory. So we can just go to the dependencies, post new web package, and search for SQlite, Microsoft Init Framework Code .SQlite, Microsoft Init Framework Code .SQlite. Yes, we apply that, and so we need say the fixture. We are going to say the new we're using SQLite database for testing, and we need our fixture say return a context of SQLite database. We say test is fixture using this database fixture. We can say public, so we will everything is possible, and disposable will say clean up as data indicated using context how to application of and let's see. We have some private and only variables. So one is db context options. db context. Context option. Which is type of application db of options of application. So we have a private read only SQlite connection. Alright, connection of connection, and so this also will be applicant db context of option. And context dot ensure this we should delete it. Connection close. And this now we can just set up the create db return a db context. So first, for the constructor public of test get this picture, the constructor is a create open connection in memory. In that case, we say create and open connection, and this create SQlite in database. Page this until the connection is closed. So we say connection equal to new height of with the data source the connection string, which will be in memory. And we open the connection. And this options will be new DB connection option builder type of connection DB context, and we specify use SQlite of options, and then we had options use SQlite connection of connection, and we have return options. And so you set our local variable to these connections options, and so in our we have the options. So now we can create a context. So we say public application DE context, and this type return, and this method will be create context. Create a context which we say var context equal to new application DB context, and we pass the options. And the context DB should create it. You should delete it. We say, yeah, we first context database that ensure deleted, and we just ensure created and return context. So to test this SQlite application database in memory, SQlite-InMemory database, we get our mark data using the initialized database. So let's create an initialized database. So private async void initialize database, and this will be application DB count of contact. So in this function, we say we create our unit test mark data over here. Let's make a transaction using transaction equal to await context not taken transfer sync, and we can try hash. Oh, basically, I test because for that later we say for that equal to list of product. So this we don't use that auto fixture, but we manually create the test data over here. So this will be a list. And in this list, the first product will be new product, and this new product has ID. Product ID equal to 1, and name equal to price product 1, price equal to 1, in stock equal to true, and inventory quantity equal to 1. We have a product and we say context dot products dot add range products, and we have order and order items. Let's first create order items. I as the order items data. So we say var order items equal to new place order item, and this will be new order item, and the object is ID equal to 1, order ID equal to 1, product ID equal to 1, quantity equal to 2 less than 10. Unit price equal to 10. And we add a context of other items, of language of other items. So next we need to create an order. Okay, we see. I test the order state, and the test orders will be stuff for order and orders of orders of order. ID will be 1. So order date will be now. Put data time of now. Figures equal order status dot ending. Okay, and maybe now we can say initialize. When we return the initialize database, with context. So now we can use our text feature for our order repository test. Instead of using this in-memory database, we need to change it to that test database feature. Options, no. Context will be text database feature. No. Okay. Test database create context database function. Create context. So in this don't need a fixture. Probably we don't say test database fixture, which is a fixture. So in this time fixture will be the test database fixture dot create test database fixture public create context. let's say, oh, this, yeah, this will be test database picture. Inject this database picture of fixture. So this fixture will be equal to fixture and bonita. So we have tested this fixture, and this context should be the fixture create context, and we pass this context into our order repository. So that's our SQL-InMemory, SQlite-InMemory test database. The context passed to our order repository. So in this case, we need modify our get orders, I think. So this we have the marked order, so we just say order ID equal to 1 for our test data, and we return order with items. So let's say so we return get ID for we have the database set up. So we say var expected order equal to await context dot orders dot include and goes to all dot items. It will return items. First default missing. All goes to dot order ID equal to order. So dot expected the result should be equivalent to the expected order. And for the through the placeholder, for the placeholder, and say this product will be first product, and we say this will be context. So we have the context products first. First of equals b dot id. The first product. However, we have this right now only have one product, and running that we have the test database. Let's initial inventory product 1 equal to product inventory quantity. And then we can create an order. So this will be product ID quantity equal 1, and active is result will be place order, and we assert first we say the check should not be now. The return the order should not be now. So now be now, and we test it. Run. So this SQlite-InMemory doesn't have a transaction. Let's see. Structure parameter picture. The fixture need a context. Fixture text the database picture. Database picture. Okay, so next will be say this is a class fixture interface of as past as database fixture, and now it will pass the database. So for the placeholder and what I say, invalid operation exception. What is equal to 1. Okay, so what happened is in our transaction, haven't finished it. That's the database fixture. What we have the test data. And we need await context dot save changes, I think. And also, you remember we are in a transaction. We need transaction that commit async. If it's exception ex or say rollback, wait, transaction rollback is true. Okay. All good. Test again. Didn't save, so it will now return that product ID of 1 for sure. Okay, now we place our first order. And so uh, this place order, it check that the place order and it check the inventory and did the operation to update the inventory. So let's say we can check it. We can check the inventory quantity. So let's say 3 dot inventory quantity. Oh, okay. No, we read that. Let's say we will now be read that. Let's see. Or updated product one. This is that which the context dot product one after the placeholder will it will always also update the inventory. So let's say product.id. So the update product one dot inventory quantity, which should be should be let's say initial inventory product one minus one, and we can retest placeholder. So you see if that inventory updated. Okay, perfect. So now we have our placeholder, the pass scenario. Everything looks fine. It's expected. Okay, so to test the error scenarios, let's say we have that when the order item quantity is greater than the product inventory quantity. So in that cases should be throw a invalid operation exception. So in that case, we just say this order async should roll back transaction. Roll back transaction on inventory update fails. Inventory update fails. So in that case, we still is using the product one and initial inventory order. In this case, we set the quantity to 20, which is greater than our quantity of 2. And we act and assert, which we say we won't catch the exception. Wait, assert that true async and what type is it? Is invalid operation exception. And this is happens on async of lambda of sister on the test of place order. So update product, which will be that still the first product, and this inventory quantity will still be inventory quantity. We should roll back and say test it. Inventory quantity of n. Oh, wait, minus of other, let's say, place order update inventory, I think. Yeah, transaction. update inventory is through insufficient inventory, and we save changes. Uh, and other stories. Oh no. Yes. Mm, okay, so relay should not be transaction. Okay, and now we can say we want to also to test because there's a rollback. This order should now be saved. Let's in order to test this order should now be saved. We can say order in DB which is equal to await, and let's say context dot orders and first update sync, and which go to all the items dot honey, and other item goes to other item dot product ID and equal to product dot ID, and other item dot and other item dot quantity equal to 20. So we want this to be now. Order indicator should be now. And because there's a transaction rollback, uh, what happened? Build. and you can see this order repository. You can see when we in a transaction, first we add this order, and what happened is if it's not successful for update inventory, if it's a less product inventory than the order inventory, so this operation will be rolled back, so that order will not add to the database. But this update inventory, we just right now we just get the inventory quantity back. Also, if it fails, we just get it back to the quantity. You can also use the transaction, but this transaction will not roll back to this. So if you want a rollback, or if there's an exception rollback, you can also set up a transaction over here. But we are not going to do that for now. And we can have let's see, we can have order service in order to get order service. We can first say define new interface of new interface of order service. Order service. And this order service, we want place order, right? So we say ask place order async, and this will be order request of order request. We need an order request. Let's create a new ETO of new class of order request. Order request. And this order request will say public int customer ID which is and public list of order item request. And edit person. And oops, items order item request new uh, order item request will be public in product ID and autocomplete public and quantity quantity characters. Alright, so we have this order request and by order service will use this. And for the service I order service place order and for the service you can add a new of orders. Order service and this order service will be inherited by order service implement into place order. So there will be all the it will need the dependency of other actually need unit of work. Unit work contain that other repository. Let's see our unit of work. We can say um, by other repository. Other repository will take a variable for other repository and this will return orders. Orders. So this will be interface of order repository. Return order repository. New order repository. And for this unit of work interface, unit of work interface, we say we expose order repository of orders, and this is read only. And for our order service, we can say now we can at the order repository from our unit of work. We need dependency injection, private, only other service. No, unit of work, a unit work of unit of work mapper. Interface of iMapper of map, and we inject this in our constructor. So public order service and inject a unit of, okay, and go to our program. We need a unit of work product service and order service. So we register this. Well, we need the interface type of order service. We return implementation of order service. Oh, here, okay. So go back to order service. Please, we can now start place